All right, so lesson 4, modeling and simplifying expressions. We're still going to do some of the stuff we did last time where we evaluate, or excuse me, analyze the expressions, but then we're going to start looking at it different ways instead of just words. So we're going to be using some diagrams as well to help us understand what the equation is doing. Because again, we're going to have to work with these equations a lot, and we're going to have to do certain things. And then we're going to talk about simplifying expressions, which today is going to be pretty easy. You've actually done those before. But we're going to use some of those ideas later on in other lessons when we get into more complex expressions. All right, so this is page 100 in your activity workbook. You can write directly in there. So examples here are looking at expressions and then diagrams to show exactly what they mean. Now, again, we're going to start off pretty simple, but they're going to get a little bit more complicated in the future. So pay attention to this, and it'll make it easier down the road. Okay, so we have an expression right here that's 3 plus 2 times 5, okay? And I'm going to show you how the expression relates to the dot diagram, or just plain old diagram if you want to call it, instead of a dot diagram below. So first thing I'm going to do is I'm going to analyze this problem for you, or this expression for you. So first thing remember is you look for parentheses. There are no parentheses. Look for exponents or powers. There are no powers. And then the next thing you need to do is circle any multiplications and divisions from left to right. Well, I have 2 times 5, so I will circle that. And then the next step in the process is to look for any leftover additions and subtractions, and I do see 1, so I'm going to exit out of there and get a different pen color, and I'm going to circle the one other part. Okay, so this says I've got 2 terms. I've got a 3 and then whatever 2 times 5 is. Okay, so then here's our dot diagram to show how they work together. So obviously we will see here we got this little white background, and then we have this blue with this different background in there. So obviously some of you are already way ahead of me. You should see right here that these 3 green dots, and again, they're different color to show that they're a different term than these blue dots, to show that that 3 goes with that diagram with the 3 dots. And then we're going to look for 2 sets of 5, because that's what multiplication is, right? Looking for sets. So here I've got 1, 2, 3, 4, 5. That's 1 set. 1, 2, 3, 4, 5. There's a second set. Yes, that's a total of 10, but I didn't just draw 10 dots. We have 2 sets, 1 rectangular set here, another rectangular set here. So that is 2 sets of 5. So I jumped ahead and did that for you. I did it in different colors to show, again, the 2 different terms are then present in the drawing too. Okay, one more, and then you guys get some more time to do that for homework and class time. So again, we want to analyze the expression first. No parentheses, there are no powers, but there is multiplication. That's 2 times d, okay? And you're looking for the other part of the expression. It just happens to be additions and subtractions. There is 1 addition left, so we'll circle that. This time I'm not doing it in different colors. And then we can show that in the diagram. Well, right here, you can kind of see the different backgrounds here. Here's our whole number. Here's our 3 dots. Okay, that's pretty easy. That's not too difficult to see. But then the harder one here is we don't know what D is, but we do know that we want 2 sets of D. So if you look at the diagram, it has a bunch of dots there, but again, it doesn't tell you the number. It has these little dot, dot, dot to show it could be 1, it could be 2, it could be 1,000. We never know. And it's okay. It's just a variable. So I should see 1 set of D dots here, a second set of D dots here. So I can circle all that to show that that is the second term. Okay. Again, D is not a number yet. Eventually we'll assign actual amounts to D. But we can see or show that this picture has 2 terms, 3, and then 2 sets of D, just like the expression, after we analyze it, show 2 expressions, the 3 and the 2 times D, but they again match the pictures. Okay? So tomorrow we're going to look at a couple more, and you'll have a chance to kind of try these out on your own, plus making other diagrams is coming up in the future too. All right, so we'll save these other ones for later. going down here to, it talks about simplifying expressions. You guys have been doing that for a long time. That's basically when we solve it. So it's just using PEMDAS to solve it. You could analyze it if you wanted to. Analyzing is just another way of showing order of operations. So they showed that here, where they circled the parentheses in 4 plus 4. Then they looked for multiplications, which is right here. Okay, because there were no powers, so I jumped to that second step, or that third step. And finally, looking for any additions and subtractions, it's right there, so we have two terms. And if you were going to solve this, you can work from the inside out, or just regularly do PEMDAS. You do parentheses first. 4 plus 4 is 8. Okay, then I'd have to do multiplication next, because multiplication comes before addition. 3 times 8 is 24, and then 3 plus 24 is 27. So basically all I'm telling you is when you simplify expressions, this is asking you to solve them. Now they're going to get more complicated to simplify when we start throwing in variables like a or x or d. But right now, if it's just all numerical expressions, all you've got to do is really solve the expression. And then finally on page 101, we're going to try to match some models to the actual expressions. And there's more than one way to write an expression, so I just want to show you that there could be two possible answers. So again, we got two colored dots, so we don't just count the dots. So that means we're going to have two different terms in our expression. So we kind of want to look for that, but we want to show what it means. Now I see that this one's in an array, and we know from, I don't know when that was, 4th grade, that when you are making an array, it usually has to do with multiplication. Okay, so I'm seeing here that I got 5 dots that are blue, and then I've got 3 rows of 7. Okay, so what I want to do is look at these equations and see, these expressions to see if any of them match. Okay, so as I look here, I got these 4 choices. Maybe all of them work, maybe none of them work, maybe 3 of them work. I don't know. That's what we got to figure out. Okay, so what I'm looking for, I'm just going to go straight down the list. So the first thing I'd be looking for would be 5 plus 3. Sorry, I had to pause the video real quick because I had a kiddo walking on me. But anyway, let's start over, or where I left off, which was right here. So I'm looking for 5 plus 3 times 7. So you could do the math if you wanted to and figure it out. But I should see 5 and then 3 more in the drawing. Well, I look here, I see 5, but I don't just see 3 more. I see 3 here, but there's a whole bunch of things. And then I would need to take this 5 and 3 more and do it 8 times. So what I'm really looking for is, if I should see this, it should be 8 groups of 7. Or, if you want to reverse it, 7 groups of 8. And I don't see that in there. Excuse me. Especially since I'm starting with 5. So I don't think that one's going to work, so I'll cross that one out. Okay, the next one, if I look at PEMDAS here, I would do parentheses. And this one shows me 3 groups of 7. Okay, and again, we talked about this before. This array kind of shows that idea. I got 3 groups, 1, 2, 3 rows of 7. 1, 2, 3, 4, 5, 6, 7. So, yeah, 7 times 3 or 3 times 7 is 21, but this array shows me a 3 by 7. So that works. And then I've got an addition, so I'm going to add 5 more. Well, those are my 5 blue dots. 1, 2, 3, 4, 5. So that one definitely works. Okay? Next one, let's check it. So I would need 7 plus 5, and then I would need that 3 times. So I'm looking maybe for something that shows me 12. Well, I can count out 12 probably if I just found 12 and randomly counted. But I would need that 3 separate times. And I don't see in my drawing 12 repeated 3 times. So cross that one off. And then let's see if the last one is 1. This one doesn't have any parentheses. So I'm going to do some multiplication first because that comes first. So I should see 3 times 7, or 3 groups of 7, then add 5 more. Well, that's very similar to this one, even though it doesn't have parentheses. So if I look at the picture, I see 3 groups of 7, that's the red. Okay, that matches with that part of the expression. And then I have 5 more blue dots. So all 3 of those, those 2, I'm sorry, I can't count, actually work. They're the same exact thing as the diagram. And that makes sense if you think about it. This one has parentheses in it. This one does not. But either way, because this one has parentheses and because this one have multiplication, it's always, those two things are always going to happen before addition. Okay. Then tomorrow we'll do a couple more. We'll see different examples. Some have variables. Okay. Some of them are crossing off or getting rid of. We talked a little bit about that maybe that very first day in algebra. And then as we move forward, you'll see much different ways to show expressions. Okay. Doesn't all have to be in arrays. It could be a little bit longer, a little bit more difficult. Okay. So you can see a bunch of different ways to show the same expression. Okay. And again, the whole point of this is to show you that, or to help you understand different parts of the equation and how you may be able to put them together to help you solve not necessarily expressions, but to solve or simplify equations. See you tomorrow.